The pursuit of knowledge begins here. Welcome to Inquisitio. Your phone's GPS only works because time passes faster in space than it does for you. Throughout your entire life, you were taught that time was the same for everyone. 1 second on a clock, 1 minute in a microwave, the exact time to arrive at work. But science has already shown that this is not true. The so-called universal time is an illusion. On Earth, time does not pass in the same way everywhere. There is a point on our planet that is closer to space than Mount Everest. And beyond Earth, the cosmos has shown that it is capable of altering the human body itself. Because the now is not unique. The present moment depends on where you are and on how you move. And this is not philosophy. It is not a metaphor. It is a real effect, predicted by physics and measured with precision. What is time dilation? Time is not absolute. According to the theory of relativity, time can flow at different rates, and this depends on two factors: velocity and gravity. The faster an object moves, the more slowly time passes for it. At speeds close to that of light, this difference becomes significant, and the stronger the gravitational field, the more time slows down. GPS satellites move faster and exist in weaker gravitational fields. For that reason, they require constant time corrections to function accurately. This phenomenon is called time dilation. It is not theoretical. It is real, and it has been measured repeatedly. In particle accelerators, unstable particles live longer than expected. This occurs because of their extremely high velocities. Atomic clocks placed in different locations on Earth record small variations in time. All of this demonstrates that the now is not the same for everyone. But this difference in time does not occur only in satellites or subatomic particles. It is also here, beneath our feet, embedded in the very shape of the planet. The question is not which mountain is the tallest. The real question is, which one is literally closer to the universe? Most people say that Mount Everest is the highest mountain on Earth. But what if highest depends on where we begin to measure? What if there is a mountain that is closer to space than Everest itself? Mount Everest is located in the Himalayan mountain range and stands 8,848.86 meters above sea level. This figure was updated in 2020 through a joint survey by China and Nepal, using differential GPS and geodetic leveling. However, the Earth is not a perfect sphere. It is flattened at the poles and wider around the equator. As a result, the summit of Mount Chimborazo is the point on Earth's surface farthest from the planet's center. Chimborazo is located in the western Andes in Ecuador and rises 6,263 meters above sea level. But when we measure the distance from Earth's center to the summit, Chimborazo reaches 6,384.4 kilometers, while Mount Everest reaches 6,382.3 kilometers. That makes the summit of Chimborazo, by approximately 2.1 kilometers, the point closest to outer space. So far, we have seen how the shape of the Earth challenges what we usually take for granted. Now, let us consider what happens when human beings leave this environment altogether. Between 2015 and 2016, NASA conducted an experiment known as the Twins Study. Identical twin brothers were carefully examined. Mark Kelly remained on Earth. Scott Kelly spent 340 days aboard the International Space Station. When Scott returned, scientists discovered something remarkable. During his time in space, Scott exhibited changes in the expression of several genes. Alterations were observed in DNA methylation, indicating physiological responses to space conditions. However, in many cases, these changes were similar to those seen during stress on Earth. In other words, they were not entirely unique to space. The composition of bacteria in Scott's gut changed during the mission. This was influenced by the station's environment, and by the space diet. After his return, those patterns returned to normal. Certain inflammatory markers increased during and after the mission. Scott was also vaccinated in space. His immune response was equivalent to Mark's response on Earth, an important finding for future long-duration missions. The primary integrated results also included temporary thickening of arterial walls and changes in metabolism. And what about actual time dilation? The study was not designed to measure time differences as described in the classic twin paradox. Nevertheless, some calculations suggest that due to orbital velocity and weaker gravity aboard the International Space Station, Scott would have experienced an extremely small time dilation effect, on the order of fractions of a second over the course of the entire mission. This aligns perfectly with the predictions of relativity, and it was not a central focus of the scientific study. All of this may seem distant, but the truth is, this difference in time also includes you. What does this mean for you? It means that every person on Earth lives in a slightly different version of time. Time is not a fixed stage on which everyone experiences the same story at the same pace. It changes with velocity, with gravity, and even with the shape of the planet itself. We also see that living beyond Earth can alter the human body, your clock, your altitude, your movement, and even your travels. All of these shape, even on very small scales, your personal experience of time. The now is shared, but it is never completely identical. And that is precisely what makes time one of the most fascinating concepts in the universe. Now that you know this, leave a comment. Would you rather live in a place where time passes more slowly, or in one where it moves more quickly? If you would like to continue exploring the hidden secrets of the universe, subscribe to the channel and enable notifications, because the next video may change the way you think about time. Until the next video.